The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. I'm Vicki Healy and would like to welcome you to today's webinar, which is hosted by the National Renewable Energy Laboratory in partnership with USAID. Today's webinar is focused on distributed photovoltaic economic impact analysis in the Philippines. Briefly before we begin the actual presentations, I'd like to go over some housekeeping items. For audio, very important, there are two options. First, you're able to listen through your computer. And if you decide to choose the computer as your option for audio, please select the mic and speakers radio button on the audio pane displayed on the right-hand side of your monitor. The other option is to listen in by telephone. And to do this, please select the telephone option on the right-hand display, and a phone number and a PIN will display. So just type those in and you'll be able to hear us speak. A gentle reminder to our panelists today, while you're not presenting, if you could please mute your audio device, that will help us prevent any background noise interference and things of that nature. A couple of other questions. The attendees, you're all on mute today, but we will be having a question and answer session following the presentation. So you'll be able to ask your questions by typing your question into the questions box, which you can also find on your the right-hand side of your screen. We are recording the session today, and we will be posting an audio and video recording of this webinar, along with PDF copies of the slide decks at cleanenergysolutions.org/training. We will also post the recording on the Clean Energy Solutions Center's YouTube channel. The links for both of those are provided on the slide. So with that, Alex Asnar at the National Renewable Energy Laboratory will now provide a short overview of this particular partnership between NREL and USAID. And with that, Alex, over to you.
Thank you, Vicki. Hello, everyone. My name is Alexandra Asnar at the National Renewable Energy Laboratory, and I wanted to tell you a little bit about the USAID NREL Partnership, which has worked on this analysis that you're going to hear about today. USAID and NREL partner to deliver clean energy, clean, reliable, and affordable power to the developing world and address critical aspects of deploying advanced energy systems in developing countries. And we do this by working on policy, planning, and deployment support, and have created a bunch of global technical toolkits. And if you want to learn more about this partnership and all the activities that we do under its umbrella, you can visit the website listed here below. Next slide. Another partner on this program and on this work today is USAID Clean Power Asia. And this program is implemented by APT Associates, and it works with the lower Mekong countries and other associations of Southeast Asian nation member states to encourage power sector investment in environmentally friendly, grid-connected renewable energy sources. And my colleague from Clean Power Asia today will be speaking a little bit more about this program during her part of the presentation. Next slide. Today, we're joined by two subject matter experts who led these analyses in the Philippines. The first is Dr. Naeem Dargouth from Lawrence Berkeley National Lab. Dr. Naeem Dargouth is a senior scientific and engineering associate in the Electricity Markets and Policy Group at LBNL, and he conducts research and analysis on renewable energy policy, both domestic in the US and international. He has a PhD in energy and resources from UC Berkeley and holds a bachelor's and master's degree in electrical and computer engineering from Cornell University and Georgia Tech, respectively, and a master's degree in energy and resources from UC Berkeley. Next slide. We're also joined here today by Subsubsuda Tongusvit, or Sophie, and she's a renewable energy consultant for USAID Clean Power Asia and an energy policy analyst at the Policy Institute for Energy, Environment, and the Economy at the University of California, Davis. And her recent research at the Policy Institute focuses on the interaction between electric vehicles and other types of distributed energy resources and the evolving industry landscape of DER deployment. So thank you both for joining us today. I think now we can turn it over to Sophie.
Hello, everyone. I'm Sophie Sudha Tongsopit, or Sophie, from USAID Clean Power Asia. I think everyone can see my screen now, right? So Alex already introduced the USAID Clean Power Asia program. I just wanted to add that we have worked in Cambodia, Laos, Thailand, the Philippines, and Vietnam on renewable energy policy planning and creating an enabling environment for renewable energy investment. Please do visit our website at usaidcleanpowerasia.org. A little bit of background on the Philippines. So the Philippines has a strong commitment to develop and utilize renewable energy resources, as demonstrated by the Renewable Energy Act that was passed in 2008. This act serves as the legal foundation for all the programs to support renewable energy in the country. So these programs include feed-in tariffs, net metering, renewable portfolio standards, and etc. The feed-in tariff program for solar power in particular has stimulated utility-scale solar investment in the Philippines by almost about 1 gigawatt, but the government has not opened a new round of FIT applications recently due to the concern on rate impacts. So for solar power, the Philippines government has shifted the focus of its policy support toward distributed solar PV through the net metering program, which has been implemented since 2013 and enable a growth of around 24 megawatts of distributed solar. Many barriers remain, as shown in this slide. So it is in this context that USAID Clean Power Asia has collaborated with the two US national labs to conduct a distributed PV impact analysis for the Philippines. Taking into account our stakeholders' concerns, we published a report that offers 3 angles of analysis on distributed PV impacts. First one is customer economic impact. Another angle is utility revenue and rate impact. And another angle is technical impacts on the power grid. But the focus of this webinar today will be on customer economics and utility revenue and rate impact only. My focus is on customer economics analysis in the Philippines for distributed PV investment. And the research question for this part is, how can the current compensation mechanism for distributed PV be adjusted to align with policy objectives? And in order to answer this question, we compare 3 compensation mechanisms and hope to review the economic viability and other implications for the Philippines. As a background, when distributed PV is connected to the power grid, there are 4 ways that they can be compensated. First, if it's designed for self-consumption mainly and there's no compensation for excess generation at all, we could call that a self-consumption scheme. But in cases where excess generation is compensated for, this can be done either through net metering, net billing, or buy or sell off scheme. I'd like to note that a buy or sell off scheme or feed-in tariffs is not a focus in the Philippines at this point. It is a scheme where all distributed PV production is injected to the power grid and compensated for at a rate designed by the government. So the focus today will be on net metering and net billing. How does net metering work? Essentially, it allows producers of PV electricity to bank excess generation as kilowatt hours credits. So when the DPV system produces electricity, that electricity will first have to be consumed, and if there's any excess power, it will flow back to the power grid. And it can be used to offset energy consumption in that month, and if there's any more remaining credit in that particular month, it can roll over in the following months and be banked as kilowatt hours to be used to reduce the bills in those subsequent months. What about net billing? One important thing to note about net billing is that the electricity that goes in and goes out of the connection point must be recorded separately. And the reason why they have to be recorded separately is because they are valued at different prices. The value of electricity that is consumed from the power grid is equivalent to the retail rate, and the exported power from the PV system is typically another rate that's set by the government and is often lower than the retail rate. The two broad categories that I mentioned, net metering and net billing, may have different variations in real world implementation. And this tree diagram represents a complete taxonomy of the different variations of net metering and net billing. And these depend on the design elements. For example, whether the credits from each month are allowed to roll over to other billing periods, and if so, for how long. In our study in the Philippines, we chose to compare three compensation mechanisms: S0, classical net metering; S1, net billing with infinite rolling credit; and S2, net billing with rolling credits and buyback. The current scheme called net metering in the Philippines that has been implemented since 2013 looks like scheme S1 here, which we give it a technical name of net billing with infinite rolling credit. And the scheme that has been proposed by the Energy Regulatory Commission in the Philippines is scheme S2, net billing with rolling credit and buyback. And the two schemes, S1 and S2, are actually very similar. They both have to measure instantaneous net consumption and net exports in each billing cycle. And if there's any excess generation in both of these S1 and S2 schemes, they're valued at blended generation rate. Rolling credits are allowed in both schemes. But in the current net metering scheme or net billing scheme in the Philippines, S1, the rolling of credits allow for an infinite amount of time, whereas in the alternative scheme, S2, there is a cutoff at 1 year. And at the end of year one, if there are any remaining credits, those credits will be paid in cash by the utility at blended generation rate. We also included classical net metering or S2 as a scheme to compare because this is also a very attractive option for customers. It was also proposed by Senate bill early last year. So this is how an example of how net billing works in the Philippines. You can see that there are the import rate and the export rate. The import rate is for electricity consumption from the power grid. It's valued at about 9 peso, and that's about 18 US cents. And whenever the PV system exports to power grid, it's valued at half of that retail rate. And that is about 4.9 peso or 10 US cents per kilowatt hour. This diagram shows our research framework and also methodology. We used the National Renewable Energy Lab System Advisor Model, or SAM, to conduct a techno-economic analysis of our designed DPV systems. The analysis is divided into the technical part and the economic part. In the technical part, the program combines data inputs such as PV system design and weather data in order to generate PV electricity production. And this PV electricity production profile is combined with the load profile in order to see how much electricity is being consumed, how much excess generation is being exported in each 15-minute interval. These data are then analyzed financially by applying electricity tariff data compensation mechanism, as well as other financial parameters. Essentially, this is to show how the cash flow for each year looks like and all the costs and benefits in each year. So then we show the results in terms of the net present value, internal rate of return, payback period, and levelized cost of electricity. Our study covers all the relevant customer groups, residential, commercial, industrial, and the associated retail tariff structures, which include residential, general service A, general service B, and general power. We focus geographically only in one utility service area, which is Morocco. And we compare the three compensation mechanisms that we mentioned before. We also ran sensitivity based on three parameters: the PV to load ratio, the discount rate, and the load growth rate. The PV to load ratio is defined as the total PV production in 1 year divided by the total load in 1 year. It is a measure of how large the PV installation size is relative to how much electricity is being consumed in a year. The base case results show that all three compensation mechanisms offer very attractive economics for all classes of customers. This can be seen from high project IRR above 16% in all cases, and a payback period in the range of 5 to 7 years. This makes sense because the retail rate of Morocco is quite high, while the cost of PV system is quite low. For example, in one study in 2016, Morocco retail rate is 11% above average for 44 markets surveyed. Our modeling also indicates that classical net metering or scheme S0 offers the most attractive customer economics in the base case. Hence, this scheme will likely promote distributed PV adoption at higher levels than the other two net billing schemes. On the other hand, if you look at S1 and S2, the two net billing schemes, there is not much difference in customer economics in the base case. One important thing to note about the results is that we got negative NPVs for the larger customer groups, general service B and general power. So we'll investigate that in the sensitivity analysis. So in this first sensitivity run, we vary the discount rate. We divide the discount rate into 5% and also 15%. And we also vary the PV to load ratio. So let's ignore the PV to load ratio for a moment and just focus on the discount rate. If you look at the upper cluster of graphs here, you'll see the positive NPV. And those are the cases where the discount rate is low at 5%. But when you increase the discount rate to 15%, you start to see negative NPVs for all customer groups in the lower clusters of the graph. So this shows what happens when we, the reason why we got the negative NPVs in the base case was because we used a very high discount rate for those two large customer groups. Another thing to notice about this chart is that as PV to load ratio increases, the net present value or NPV consistently declines for all three compensation mechanisms. This means that it makes sense to size the system not too large. That is, the PV to load ratio should not be too high. For net metering, this is because the way we design the scheme, we set the the banking period at 1 year, and at the end of the year, if there are any remaining credits, those credits are cut off to 0. Therefore, it doesn't make sense to size the PV system too large because you end up with remaining credits that cannot be used at the end of the year. In the two net billing cases, the larger PV system size, the more excess generation, which is paid back to you at a relatively low rate, at blended generation rate as we've seen before. Therefore, it makes sense again to size the PV system just enough for self-consumption and avoid grid injection. In the next sensitivity run, we investigated the results from varying PV to load ratio and varying the load growth rate. On the left panel, we show the results of having a very high load growth rate of 20%. On the right panel, we show the results of a low load growth rate of 0% or no load growth at all. At a high load growth rate of 20%, customer benefits of S2 are almost the same as S1, except for cases when PV to load ratios are very high, then the IRRs will be slightly better. But when you lower the load growth rate to 0%, you started to see the case where S2, the cases where S2 begin to offer larger IRRs than S1 and even S0. And this is because when there are a lot of remaining credits in cases of high PV to load ratio, the excess electricity under S0 and S1 will not be used toward bill reduction. But in the case of S2 or the scheme that the ERC has proposed, those credits will be reimbursed to customers in cash at the end of the year. So the same trends also apply to the other two customer groups, where S2 or the ERC scheme starts to look better than S1 and S0 when the PV to load ratios are very high. So in summary, classical net metering of S0 offers the most benefits in most sensitivity cases. And the current net billing scheme, or S1, will likely discourage oversizing of DPV systems and encourage self-consumption rather than grid exports. The scheme S2, or the ERC scheme, has an advantage over the current scheme in cases of very high PV to load ratios or no load growth. But such conditions will likely to be rare. And therefore, the proposal of S2 or the ERC scheme as an alternative to S1 provides no additional economic advantage to customers if impacts are measured in terms of NPVs, IRRs, and payback periods. However, the introduction of S2 may have a slight advantage in offering cash payments, which may be psychologically beneficial to those customers with less disposable income. In this month, the government of the Philippines has launched a draft circular called Policy to Enhance the Net Metering Program. And the main highlights of this revision of policy include three things. First, the adoption of multiple compensation mechanisms for the current net metering program. Second is the lifting of the 100 kilowatt cap, which was imposed before in the net metering program, meaning that from now on, systems above 100 kilowatts can now be compensated for their excess generation. And third is the use of systems above 100 kilowatts as emergency supply. And I'd like to talk a little bit about the multiple compensation mechanism, which is a major policy shift in the Philippines. So this proposal of multiple compensation mechanisms includes net metering for residential customers and net billing for larger customers, including commercial and industrial customers. And this represents a compromise considering competing stakeholders' interests. For example, on the one hand, there are concerns that the current program in the Philippines is not providing enough incentives to induce market growth. But on the other hand, if there is an accelerated growth of DPV, utilities become concerned about unfairly subsidizing DPV customers by non-DPV customers. So they have proposed classical net metering for residential customers because it's easy to understand by customers. It also provides a very strong investment incentive. And it has already been proposed by the Senate bill On the other hand, net billing may be a better option for larger customers because they align well with the current policy to promote self-consumption only. And also, for larger customers, it's important to note that even without any compensation mechanism for exported generation, the market has continued to expand in this sector for self-consumption only. So the proposal of net billing for larger group is already very incentivizing. And even though it provides a less strong incentive than net metering, it also yields a payback period of 5 to 7 years, as has been shown in our analysis. And also, net billing can prepare larger customers better for future changes because the export rate can be varied. And in the future, it's more likely that the export rate will be designed to match with the value of distributed PV to the system. And that concludes my part of presentation. I'd like to pass the microphone to Naeem Dagoos for the revenue and rate impact analysis. Thank you.
Great. Thank you so much, Sophie, for that. My name is Naeem Dagoos. I'm a researcher at Berkeley Lab in the Electricity Markets and Policy Group. And I'm going to be talking today about a complementary analysis to Sophie's. So Sophie presented the customer economics of solar and how the various compensation mechanisms impact the customer economics of solar. I'm going to look at the utility side and the ratepayer side of the distributed solar program in the Philippines. So what I'll be focusing on is how the distributed solar program in the Philippines impacts utility revenues as well as retail rates. And moving here. So the objective is to provide the Philippines Department of Energy and other stakeholders in the Philippines and of course beyond with analysis to really evaluate those impacts that I discussed on net revenues for the utility and retail tariffs. So to be clear on the scope, this is kind of a short-term analysis. We're looking at 5 years. And what this enables us to do is to assume that the generation mix stays constant over the 5-year period. So we don't assume that kind of new generators will come into online to account for greater renewable penetration, for example. We also don't assume that the tariff structures change over time. So we use current tariff structures, but of course with potential changes in the levels of the tariffs. And for this, we're using the Meralco service territory. So Meralco is a privately owned distribution utility that serves Manila, the capital, as well as surrounding regions. It's also the utility that currently has by far the most net metered and customer connected distributed solar. And so we've chosen to use Meralco as our principal case study here. So I'm going to start with providing some idea of the analysis framework. And I think the framework of analysis can be much more widely applicable beyond the context of the Philippines, though of course what this framework, the impacts of this framework and the implications of the framework on the results will depend on a number of factors, including the compensation mechanism that Sophie discussed, as well as the regulatory framework, how changes in net costs are either going to be impacting retail rates or net revenues. So I'm going to walk through this chart kind of step by step, but starting with DPV deployment. The deployment, so distributed PV generation, can either be self-consumed when the solar system is behind the meter. The instantaneous generation, if there is load, will be used on site. And so that is self-consumed PV generation. Any PV generation that is greater than the customer's load will be injected into the grid. And these are injections. And for many compensation mechanisms, or the self-consumed generation and the DPV grid injections will have different financial impacts for the utility. So self-consumed generation will lead to reduced electricity sales, and grid injections may be paid differently depending on the compensation mechanism. But something to note is that all PV generation will lead to some utility cost reductions as well, right? So because because that electricity is being generated by the consumer, the electricity doesn't need to be generated and acquired by the distribution utility. And so there are reductions to utility costs. So the net financial impact is kind of a combined result of how much the utility is paying for that electricity and their avoided costs from the utility. So when you add all these together, in the Filipino context, the regulation for rate making ensures that any change in costs due to a distributed solar program is going to lead to changes in retail rates and won't impact the net revenues or profitability of the utility. And this really is something that is going to depend on exactly how the rate making regulation is written, and will depend from will change from one country to another. But in the case of the Philippines, the Electricity Regulatory Commission, which is the main regulatory body in the Philippines, has set up rules that really protect the utility from any changes in net costs, whether they be a result of solar or even energy efficiency, which can, of course, reduce electricity sales over time, or at least keep them stable in environment of growing number of customers. And so what this means is that this net impact is going to lead to changes in retail rates. So in the next few minutes, I'm going to go over a few more details quickly before presenting the results of the analysis. So as I mentioned, the first step is to quantify the self-consumption and DPV grid injection. So the self-consumed generation means that if they're producing that electricity, if the consumer is producing their own electricity, they're buying less electricity from the utility. And so that leads to reduced electricity sales for the utility. Any grid injections are compensated at some level. Under net billing, they're compensated at, in the Philippines, at a blended generation rate. For commercial customers, as Sophie mentioned, residential customers will now be allowed to do full net metering, which means that any grid injections are actually compensated at the customer's retail rate as well. And on the avoided cost side, the utility is going to avoid energy costs. So that's basically fuel savings from conventional generation. Again, because that electricity is being produced locally, the utility doesn't have to acquire that electricity to deliver to the customers. So that, of course, is a savings. There are potential capacity cost savings, and that's in terms of basically solar could reduce the need to build new generators to serve peak load. So if the peak load can be reduced, that means that you don't need to build as much generation capacity to serve that peak load. And so there is a value to the distributed solar in terms of capacity costs or avoided capacity costs. And of course, because that generation is being consumed on site, that means it doesn't need to be transported through the transmission distribution network, which avoids, again, those losses associated with a conventional generation. And so those are the main utility costs that are avoided. Now, distributed PV can impact other utility costs, especially if you have higher DPV levels. And this includes reduced earning opportunities because you defer or avoid transmission and distribution capacity investments. This could mean line loss reductions as you have voltage boosting over the distribution network. You could have some program administration costs, and these, as well as integration costs more generally, haven't been included in the analysis, again, because we're looking at a short-term analysis with relatively modest levels of PV deployment as per the targets. So the question is this decrease in revenue from self-consumption and the cost of the exports greater than or less than the decreased costs from all DPV generation? And this is going to really result in a net increase or decrease in retail rates. So generally, the decreased revenue from self-consumption and exports, if it's at the full retail rate, are actually greater than the decreased costs from all DPV generation. And this, of course, leads to increases in retail rates because you have a net cost to the utility that's recovered through the rates. And so, again, you have an increase in retail rates. Now, let's start with a few key findings before diving into the results. So the first one is that the regulatory structure in the Philippines really prevents significant distribution utility net revenue erosion. So retail rates are designed to recover all costs from the utility using forecasted future revenue requirements, which is, I would say, relatively unusual and really is meant to fully protect the utility, and therefore DPV has a minimal impact on the profitability and the profits of the utility. In Meralco's in Meralco's kind of case that we've looked into more detail, the retail electricity rate impacts are limited, and we expect them to be a less than 0.5% increase in the average tariffs for every 500 megawatts of DPV, and that rate impact gets slightly higher as you increase PV deployment because the value of the solar decreases as you increase DPV deployment. And the highest rate impacts are for residential and small commercial customers, and we'll quickly discuss as to why this is. And of course, the results here are presented from Meralco, but lessons really can be learned from all private distribution utilities in the Philippines, and there are also kind of broader conclusions that can be made beyond the Philippines as well. So this chart here shows the retail rate impact with increasing Meralco DPV capacity, given our modeling assumption. So the blue line is the average or total change in customer tariff, and we see with 2 gigawatts of distributed PV capacity, which is the approximate target level for the and is relatively aggressive in terms of Meralco's service territories deployment, we see an increase in the customer tariffs of only about 2% overall. Now, the residential tariff is a little bit higher than the average, and so that's if you recover all net costs for residential customers alone. You find that there's a slightly greater increase in customer rates, and that's because most of the customer rate for residential customers is a volumetric per kilowatt hour rate that solar can displace. Other customers, especially large power customers and larger general service customers, which are larger commercial customers, have some of their rate that's recovered, or some of their rate is a demand charge, and solar isn't as good at reducing it. And so the impact, the cost impact of customers with solar, or those rate classes with solar, is lower, and that's why you see a lower increase in the customer tariff. So as with Sophie, we've considered both a net billing as well as a net metering. And as you go from a net billing, again, where net billing is compensating a distributed solar at a avoided cost or a blended generation rate. So any any electricity that's injected into the system is compensated at this lower rate, which is a blended generation rate. And because it's lower than the retail rate, the impact on rates is also lower because that net cost that needs to be recovered over rates is lower. As you move towards net metering and those injected the injected electricity is compensated at the full retail rate, you'll see an increase in the retail rate impact because the average compensation or the average cost to the utility for each kilowatt hour on average is higher. For larger customers, because until recently, larger customers or all customers were limited in the size of the PV system to 100 kilowatts, most of those customers didn't inject much into the grid. All of that electricity was self-consumed. So the net impact from net billing or net metering was the same, because basically all of it was self-consumed, all of that electricity self-consumed, and therefore it leads to changes in sales, and what is the compensation rate for injected electricity is not relevant. So that's why you see this yellow line is flat. So again, why are these tariff impacts so low? Well, one thing is Meralco has been able to keep the customer rates low. And they do that, and what this means is that the difference between the customer tariffs and the value of solar generation is also low. So that means that that difference that needs to be recovered through rates isn't very large. For larger commercial industrial customers, bill reductions are all even lower because the volumetric rates are a smaller proportion of the customer's total electric bill, which means that because those fixed customer charges and demand charges are only minimally impacted by distributed PV, the difference between the average cost of per kilowatt hour and the value to the utility are even smaller, leading to smaller tariff impacts. So a couple of conclusions before turning it back to Alex and hopefully having a few minutes for Q&A. Is that the utility financial health is protected by the regulatory structures and the rate-making rules. Rates are designed using forecasted sales and revenues, accounting for DPV generation, and this really ensures full cost recovery for the utilities in the Philippines. The tariff impacts from DPV are limited, as we've seen. So our analysis has shown that tariffs increase by less than 1% on average for 1 gigawatt of DPV in the Meralco service territory. So hopefully this has given you an idea of not only the results, but kind of the general approach that's taken to do this kind of analysis. And of course, the results are going to really depend on both the regulatory structure and retail rates, as well as some of those avoided costs. So with that, I'm going to turn it to Alexandra Aznar, who's going to finish up with some of the recent progressions and what's been happening recently in the Philippines.
Thank you, Naeem, and thank you, Sophie, for your presentations. So there have been some new updates in the Philippines with regards to net metering and distributed PV. And these analyses that Sophie and Naeem were speaking about on customer economics, utility revenue impacts, and then technical impacts, which were not presented today, were done in collaboration with the Philippines Department of Energy to really support some of their decision making on the issue of distributed solar. And the latest update that we see is that in October, the Philippines Department of Energy issued a draft circular on their net metering program. And a draft circular, or a DC, is a policy document, essentially. You can see these clips here from the website that the DC on net metering is open right now for public comment. And the actual language of the DC, there's a picture here on the lower right, and you can go and review what that entails. Next slide, Vicki. Next slide. So as Sophie alluded to, there are some key components of the draft circular that change the net metering program from its original version to this newer version. And again, those changes are out for public comments that will be incorporated into a final policy document. So the draft circular allows for classical net metering at the full retail rate for residential customers. And then it allows for the Philippines' current net metering, which is actually technically a net billing scheme for commercial customers at the blended generation or the time of use rates. It also, as Sophie mentioned, kind of opens up compensation to users who have systems above the original 100 kilowatt threshold. So there's a new classification of customers called own use RE systems above 100 kW, and they can export excess energy to the grid under certain conditions. There are some limitations placed on the capacity based on the average annual peak demand. Some more details about that in the draft circular. And the pricing methodology for the compensation is going to be determined by the regulator in the Philippines. The draft circular also outlines some obligations for distribution utilities in the Philippines, and it's asked them to conduct distribution impact studies on a feeder-specific level and publish the capacities available for the net metering program and the own-use RE systems so that those are publicly available for customers and installers. Next slide. So currently the draft circular is going through a series of public consultation events in the month of October. And the objective of these is to solicit feedback from the public on the contents of this draft circular. To date, there's been 2 public consultation events, one in Manila and one in Cebu, and there's also one this Wednesday as well. And then the Philippines Department of Energy will be incorporating the inputs from those public consultations and finalizing their draft circular at a future date. This picture here on the bottom right is a photo from the public consultation event in Manila. Next slide. So with that update, I'd like to turn it over to the Q&A session for Naeem and Sophie. So we're open for questions, and please add your questions in the question box. Okay, we have a first question here, and I think this question is for Naeem about the utility revenue impacts. And so you mentioned in your results that the retail rate impacts are relatively low at 0.5%. And so the person asking is curious, in what context would retail rate impacts from DPV be lower or higher than what you found in your analysis?
Great. Yeah. So there are a number of reasons why. So let's start with higher retail rate impacts. Higher retail rate impacts would often mean that, so what this would mean is that the costs to the utility are greater than the value of that electricity being generated. And there are a number of reasons why this could be. In some cases, this would mean that there are high retail rates being displaced. So, for example, in some countries, you can have residential customers on inclining block prices, and the largest customers are the ones paying the most. So if they have solar on their roofs, they're displacing those high prices, which is the greatest cost to the utility, because in terms of reduced sales. And so if you have higher costs to the utility, the difference between the costs and the value of that solar are going to be greater, and that's going to lead to increased retail rate impacts. That said, even in contexts where that is the case, other analysis done on this in various contexts has never found a very large impact on retail rates. Of course, this is going to depend on the exact context, but it often for 1 or 2% penetration rate, it's rarely much more than 1 or 2% increases in rates. Retail rate impacts could be lower when the value of the PV electricity is high. So in contexts where perhaps there's a high price of electricity in midday due to air conditioning, that could lead to high avoided costs from solar. And therefore, if your avoided costs are higher, that means that the difference between the utility reductions in costs and the value is lower, and the retail rate impacts are lower. So those would be, I guess, 2 examples.
Great, thank you, Naeem. We have another question that's come in, and this one is for you, Sophie. You mentioned in your key results that the customer economics of distributed PV investment in the Philippines, even under the original net metering program, are already quite good on a variety of metrics, from payback period to IR. So why hasn't the installed capacity really met the expectations of stakeholders in the Philippines? Why is the investment still quite low?
Hi, this is Sophie. Yes, so in the Philippines, there's a lot of interest in rooftop solar, but the installed capacity so far under the net metering program on net billing has been only around 20 megawatts. And that's because, as I listed in one of the slides, but it's been discussed, is even though the economics is good, but there are many, many barriers. And the main ones are the interconnection process with the distribution utility is quite long. Originally, each utility requires a distribution impact study for every individual installation, including the smaller ones. So this draft circular has tried to address that to some extent. And also the permitting processes really depend on different local governments. So there's no standard, and it's vary from one local government to the next. So that's why these are the two main barriers that prevent customers from being able to move forward with the investment, and also the lack of financing, especially for the residential scale.
Okay, thank you for that explanation. I think we have another question here about the utility revenue impacts. And Naeem, you were speaking a little bit about the avoided costs from PV generation. Could you provide some more details on the methods you use to calculate the avoided costs from PV generation?
Sure. So I'll give some kind of general details on the methodology. So usually the energy value is the largest piece of the value of solar, or the avoided costs from solar. And the energy value can be calculated in the short term using data on the dispatching of generators each hour, and what generators would be displaced through solar each hour over the year. For the Philippines, they actually have pretty detailed data on the wholesale electricity spot market generator bids. And so we can recreate the supply curve for electricity supply and generation each hour. And that enables us to understand, with increasing PV, what is that price? What is the marginal price and the average price of electricity that's being displaced each hour by solar generation? And then we can then sum it and take a weighted average over the year. So the average weighted on the PV generation, to understand exactly what is the average value over the year of that PV generation. So that, again, is a method that you can use when you have kind of a detailed data on this. And I would refer you to the report that we wrote on the Philippines Clean Power Asia, and I would encourage you to take it. In any case, more details are in that report, and more details are also in other reports that we've written.
Thanks, Naeem. We have another question that's come in, and it may be more addressed from the technical part of the report and analyses, but I wanted to open it up to both Naeem and Sophie. What are some of the implications of your analyses and results on distribution planning, and how regulators and system planners can think about distributed PV as they go about improving the integration of DPV and planning for the future?
I can start with that. So it's important for one strategy of limiting retail rate impacts or net revenue impacts for utilities where that's appropriate is to have solar encouraged in the distributed solar encouraged in the areas that are highest value to the utility and therefore to ratepayers. And so including solar in trying to incentivize solar in those areas will aid with distribution planning, and potentially even offset some of those distribution investments. And so to kind of include distributed solar in kind of a holistic planning exercise, and kind of have a feedback such that the rates are set in such a way to encourage solar in the kind of highest value areas will be important to technical issues around distribution planning and investment, but also limit retail rate impacts.
Hi, I'm Sophie, and the implications for distribution planning from the customer economics analysis is really, it depends on the detailed design of the compensation mechanisms. So originally, the current net metering scheme, which is essentially net billing, as I have discussed before, it has discouraged grid injection, meaning that the investors wouldn't be interested in sizing the system too large, and they would just size it enough to meet their local consumption. And that means that it actually may benefit the utilities in not utilizing the distribution systems too much. So that can be quantified in terms of the avoided investment in the distribution system. On the other hand, if the government were to switch to net metering for residential customers, if they allow lots of net metering with no limit on grid injection, and allow infinite rolling credits or payments at the end of the year when they have a lot of remaining credits, in that case, the customers can potentially size the system quite large, more than their load, and produce more grid injection. And in that case, it could also benefit the system, because currently the government has experienced power capacity inadequacy. They have had many rate alerts in the past. So that grid injection can actually contribute to serve the load during the day. But then the distribution planning, from the distribution planning perspective, they probably have to plan for the flow in of power from the system. But at the same time, if they design the net metering to have some cutoff, like setting the credits at the end of the year to zero, like what we did in the modeling, in that case, that wouldn't be a problem. That's all from my comments.
Yeah. Thank you both for your answers and insight on that question. And we have one more question that I think you could both weigh in on. And that's how can the Philippines learn from the lessons learned and best practices from some of the leaders in DPV deployment, such as Germany and some states in the US, where there are significant levels of distributed PV deployed. And as the Philippines is going through these program changes and trying to increase the efficacy of their program, are there some lessons learned from those leading jurisdictions in DPV deployment?
Yeah, sure. I can start with that. So the first thing to note is that Philippines actually has a pretty advanced regulatory framework and system set up. So they really are using kind of, I would say, state-of-the-art regulation for electricity rate setting. There's kind of a performance-based incentives for utilities, which have kept rates relatively low and kept kind of the performance and efficiency of the utilities high. So I would note that that the country is quite advanced already, and so we should. Yes, there are things to learn, but the Philippines is actually doing quite well in terms of managing and regulating their electricity. There are some lessons learned to be learned from some U.S. states and other some countries. That said, what's the big difference between, let's say, Germany or U.S. States, California, for example, and the Philippines is that California, Germany, other countries have developed their solar markets when costs were relatively high, and there were high subsidies were needed to make the investment attractive. Whereas now we're in a very different market where prices are low, and the market could grow significantly because there are enough incentives for adopting solar. And so the way that solar is going to be adopted won't be quite the same as how things were adopted in these other contexts. That said, there are policy mechanisms to limit rate impacts, for example, or profitability impacts by setting, for example, system caps that would automatically trigger revisions of particular policies. So once Meralco arrives at a target of 1 gigawatt, that could automatically trigger a study to understand what the impact has been to the grid, both in terms of rate and technically, and see if the policies that have been adopted should continue or should be revised. And I think that's a strategy that's been taken in many countries and contexts, and I think that that would be very valuable for the Philippines going forward. And then also just a sharing of experiences with other countries in the region is valuable to understand some of the challenges that exist in the Philippines are not the same as those in some of the early adopting countries. And so learning from regional utilities and regulators would be valuable as well.
Hi, I'm Sophie, and I agree with Naeem that the Philippines has been quite advanced in terms of their policy design. One thing to note about the Philippines is that, like in Germany or the US, for the net metering program or program to support distributed solar, they don't really have like a megawatt cap in terms of like policy cap in the next few years. So it allows the market to continuously expand, unlike in many other Southeast Asian countries that whenever they support distributed PV, they'll have like a megawatt cap in terms of policy. But having said that, in many US states, they also have like a cap in terms of like the total system peak demand in order to be able to manage the DPV deployment technically, and also because of the concern on rate impact as well. So that's something that the Philippines can keep in mind, is to have some kind of cap that is tied to reasonable technical estimate, but at the same time, it doesn't slow down the market. Another thing about the Philippines is that just like many other countries that have supported rooftop solar before, they have experienced like some sticking points regarding permitting process and interconnection process. And Germany and the US probably experienced that like maybe more than 20 years ago. But the Philippines recognizes all these problems, and they are trying to change that step by step. And I forgot to mention that for permitting process, they have passed a law that would make it easier to do transactions with the local government. So that is nickname of it is one-stop service law. So that will hopefully make it easier to streamline the permitting process for distributed PV investment.
Okay, thank you both for those insights. I think we have one final question to wrap us up today. And for both of your analyses, you focused on the case study of Meralco, which is the main private utility that serves Manila and the surrounding region. And could either of you or both of you speak to any implications your results might have for other distribution utilities in the Philippines? Yeah, that's the question. Thank you.
Can you repeat the question? Again, sorry.
So your analyses, both on the customer economic side and the utility revenue impact side, focused on the Meralco case study. Can some of these results, do they have implications on other regions in the Philippines or other distribution utilities in the Philippines?
Yeah, so for the customer economics, we did the focus on Meralco only. And if we were to apply to do the analysis for other distribution utilities, we're going to have to change the welfare data. We're going to have to change the retail rates. But due to the market in the Philippines, they have like quite low prices thanks to the influence of imported panels from China. And also retail prices, I guess, in different utilities, they wouldn't be that much different. So in that case, it's very likely that the customer economics of the PV investment for customers in the Philippines in general would be quite good. Payback period, not more than 10 years, positive NPV, really high IRRs. So that's my part. What do you think about your part, Naeem?
Yeah, so I would say, I mean, it's hard to say for sure without doing the same analysis, but for privately owned distribution utilities, again, they are regulated in the same way, so all of the impacts will be on retail rates. Depending on how much, so of course, 1 gigawatt in Meralco, it represents just a few percent in terms of PV percentage of total energy. 1 gigawatt may represent much more for a smaller utility, and therefore the rate impacts may be larger for those utilities.
Okay, thank you both for those answers. So that's going to really wrap up the end of this webinar today. If we didn't get to your question, we'll make sure to follow up the email. And thank you for all the attendees for joining today. And thank you to both of our panelists. We appreciate your time.